Hey, come join me walk. As today we're delving into descriptive analytics, and our focus is on understanding it from a high-level perspective. We're steering away from deep technical details to embrace a broader view of its purpose and value. So, what exactly is descriptive analytics? At its core, it's about answering the question, what has happened? It involves organizing and summarizing historical data to get a clear picture of past events and trends. Why is this important? In the field of data science, descriptive analytics serves as the foundation for all subsequent analysis. By clearly understanding what has happened, we can set the stage for deeper inquiries. It helps us identify patterns, spot trends, and get a sense of the overall data landscape. This foundational step is crucial because it informs the next phases of analytics: diagnostic, predictive, and prescriptive. For instance, before we can analyze why something happened, diagnostic analytics, or predict future outcomes, predictive analytics, or recommend actions, prescriptive analytics, we need to have a clear and organized view of the past. Descriptive analytics helps us achieve this by providing a structured summary of historical data, allowing us to see key insights and trends. In practical terms, descriptive analytics involves tools and techniques that organize data into meaningful categories, visualize it in charts and graphs, and summarize it using statistical measures. This high-level overview helps you quickly grasp the essence of past data, making it easier to build on this understanding in your further analysis. By focusing on descriptive analytics, you're equipping yourself with the essential skills to interpret historical data effectively, setting a solid foundation for tackling more complex analytical challenges. So let's embrace this high-level perspective and appreciate how it paves the way for deeper insights and informed decision-making. So, let's start with descriptive analytics. You can think of it as having two main pillars that simplify our understanding of data. The first pillar is describing the data. This involves organizing raw data into a structured format so that we can clearly see what's happened. The goal here is to take a complex, jumbled data set and make sense of it by breaking it down into meaningful groups and categories. The second pillar is summarizing the data. This takes the described data and compresses it further into a more digestible form, highlighting the key insights and main trends. Summarizing involves calculating measures like averages, medians, and standard deviations, and visualizing the data through graphs and charts. The goal is to simplify the data further into a clear overview that captures the essence without getting lost in the details. Describing and summarizing together help us gain a comprehensive understanding of past events and trends. Describing organizes the data, while summarizing distills it into key takeaways. This dual approach ensures that we have a clear, structured view of historical data, making it easier to move on to more advanced stages of analysis. By mastering these steps, we lay a solid foundation for exploring deeper insights and making informed decisions. Let's delve deeper into the concepts of summarizing data, central tendency, dispersion, and distribution, and explore why each is crucial for understanding data shape. Central tendency helps us identify the center or typical value of the data. It answers the question, what's the central point around which most of the data points cluster? Measures like the mean, median, and mode provide a snapshot of this central value. Knowing the central tendency is important not just for having a reference point, but also for understanding the general behavior of the data. It helps us assess how typical or atypical individual data points are relative to the central value. For instance, if we know that most of the data is clustered around a certain value, we can make informed predictions and decisions. This central value often acts as a baseline or benchmark, which is particularly useful in fields like quality control or financial analysis. In more advanced discussions, this central value also relates to concepts like maximum likelihood, which helps in estimating parameters for probabilistic models. Dispersion describes how spread out the data points are around the central value. It measures the variability or consistency within the dataset. Key dispersion measures include the range, variance, and standard deviation. Understanding dispersion is crucial because it tells us whether the data points are closely packed around the central value or dispersed over a wider range. If the data points are tightly packed, it indicates low variability and more consistency. This can be reassuring in situations where consistency is desirable, such as in manufacturing. Conversely, if the data is widely spread, it indicates high variability, which can be important for understanding risks or uncertainties. High dispersion can reveal underlying issues or trends that need attention, while low dispersion might suggest stability or predictability. Distribution provides insight into how data points are spread across different values. It shows the overall shape of the data when visualized, revealing patterns such as clusters, gaps, or skewness. Common shapes include normal distributions, which resemble a bell curve, or more specialized distributions like Poisson or binomial distributions. Understanding the shape of the data is important because it helps us identify patterns and anomalies. For example, a normal distribution indicates that data is symmetrically spread around the mean, while a skewed distribution reveals that data is unevenly spread. Recognizing these patterns helps in choosing appropriate statistical methods and making informed decisions based on the data's characteristics. By combining central tendency, dispersion, and distribution, we gain a comprehensive view of the data's shape. This holistic understanding allows us to interpret the data more effectively, identify trends, and make informed decisions based on a clear picture of how the data behaves. Up next, let's look at a case analysis highlighting this concept in a real-world scenario. Meet Alex, a data analyst at a thriving e-commerce company. Alex's job is to understand customer purchasing patterns to guide the company's marketing strategies. Let's walk through how Alex uses descriptive analytics, supported by GPT, to achieve this. First, Alex describes the data. The process starts with collecting transaction records from the past 6 months. This raw data includes details about customer purchases, amounts spent, and purchase frequency. To make sense of this data, Alex organizes it into meaningful categories with the help of GPT. For instance, Alex might prompt GPT, "Can you clean and categorize this transaction data by product types and spending amounts?" GPT assists by correcting errors, sorting transactions, and structuring the data into a clear, organized format. This transformation allows Alex to clearly see what's happened in the data. Moving to the summarizing phase, Alex starts by exploring central tendency, finding the average, median, and mode of spending amounts. Alex prompts GPT, "Can you calculate the average, median, and mode of the spending amounts?" GPT quickly computes these measures and provides insights like, "The average spending per transaction is $60, and the median amount is $50, with $30 being the most common." This helps Alex understand the typical spending behavior and provides a reference point for further analysis. Next, Alex examines dispersion, which measures how spread out the spending data is around the central value. With GPT's help, Alex asks, "Can you calculate the standard deviation and variance of the spending amounts?" GPT delivers insights such as, spending varies significantly, with some customers spending as little as $10 and others as much as $200. Understanding this variability helps Alex gauge whether spending is consistent or varies widely, which is crucial for identifying which products or customer segments exhibit high or low variability. In analyzing distribution, Alex uses GPT to visualize and understand how spending amounts are spread across different values. Alex might prompt, "Can you create a chart showing the distribution of spending amounts?" GPT helps generate graphs that reveal patterns, such as clusters around certain price points or a skewed distribution. For example, GPT might highlight, "Most customers spend around $50, but there are noticeable spikes at $25 and $100. This visual representation helps Alex identify spending trends and patterns. Combining these insights from central tendency, dispersion, and distribution, Alex gains a comprehensive view of the data's shape. GPT's assistance in summarizing these aspects turns complex process into quick and easy one, allowing Alex to have more time to analyze and make informed recommendations for pricing adjustments, targeted promotions, and inventory strategies. In essence, Alex's use of descriptive analytics, backed by GPT's capabilities, turns raw data into a structured, insightful narrative. By asking targeted questions and using GPT to process and analyze the data, Alex can effectively understand past purchasing behavior and guide future business strategies. Having explored descriptive analytics, we now have a solid understanding of how to summarize and interpret data through central tendency, dispersion, and distribution. This foundational knowledge is crucial as we transition to the next phase of analytics, diagnostic analytics. So, why is descriptive analytics so important for diagnostic analytics? Once we have a clear summary of past events, including how data points are distributed, their central value, and their variability, we set the stage for deeper exploration. Diagnostic analytics takes us a step further by asking, why did this happen? It builds on the insights gained from descriptive analytics to investigate the underlying causes and factors behind observed trends and patterns. With a comprehensive summary of past data, diagnostic analytics helps us identify correlations, patterns, and anomalies that can explain why certain outcomes occurred. It allows us to delve into the why behind the data, uncovering relationships and causal factors that might not be immediately obvious from a surface-level view. In our next episode, we'll dive into diagnostic analytics, exploring how to analyze the reasons behind trends and anomalies revealed through descriptive analytics. We'll look at various techniques and tools used to uncover causal relationships and understand the deeper dynamics of your data. To support your learning, I've also attached a list of sample prompts that you can use when working with generative AI. Stay tuned as we move from understanding what happened to investigating why it happened, setting the stage for predictive and prescriptive insights that can guide future actions and decisions. Thanks for joining today, and I look forward to seeing you in the next episode, where we continue our journey through the phases of analytics. Thanks for walking with me.